All right, today we're going to look at our third type of word problem, age problems. These ones are solved usually using a little system to keep track of your givens and your data. Usually we use a chart. An age problem is characterized by this. You compare ages of people in two different periods of their lives. First example is actually an easy one. There's only one period of their life. A mother is 3 years less than 5 times as old as her daughter. If the sum of their ages is 39, find the age of each. So I'm going to start by saying, all right, I'm going to let x equal the age of the daughter, which means that the mother is 3 years less than 5 times as old. So that's a 5x minus 3. And then it doesn't say in the future, in the past. It just says right now, if the sum of their ages. How do you sum things? Well, you add them together. So the daughter plus the mother means equals 39. And that's a really easy example. The booklet has this as example 3. I decided to do it first because it's the easiest one. So if you're looking at the booklet right now, look at example 3. This is just a simple type 3 equation. It takes 3 steps to solve it. Actually, it's a type 2 equation. It takes 2 steps to solve it. The first step is, no, type 3. I was right the first time. Type 3. First step is collect those two like terms. So 6x minus 3 equals 39. There. Now it's a type 2 equation. The next step is to add 3 to both sides. The next step is to divide both sides by 6. And now a conclusion is necessary. And for my conclusion, I will say, therefore, daughter is 7. And don't forget that it asked for the age of each. If you stop there, you'd lose half a mark. The mom is 5x minus 3. So I have to take this 7 and go, gee, what is 5 times 7 minus 3? I'll just do that as scrap work. That's 35 minus 3, 32. And there we go. That would be full marks. Don't forget when you do these problems, we just did a little mini quiz and a whole bunch of people forgot this step. It counts. That's at least half a mark when I test you on these. So there's the first example. I'm going to do the examples in the reverse order. So next I'm going to do example 2, which is a little tougher because now there's 2 time frames. John is twice as old as Bill. In 5 years, the sum of their ages will be 34. So I'm looking at 2 people, John and Bill. But I'm looking at them at 2 different time frames. Now and in 5 years. Now, if you're following along in the booklet, you're going to see they do this exactly the same way as me. Right now, John is twice Bill. So it would logically make sense to make Bill's age x and John's age twice x. 5 years from now, no matter what these 2 numbers are, in 5 years, they're 5 bigger. Now, the second sentence tells me what to do with this row of my chart. In 5 years. So it tells me, look at this row in 5 years. And I like to do this in a kind of a color-coded style. The sum of their ages. What's sum mean again? That number plus that number. Will be is just the future tense of saying is. So that's where my equals goes. And of course, 34 is the other side of the equation. So once again, it's a pretty simple little type 3 equation. Step 1, add together my like terms. Step 2, minus the constant from both sides. Step 3, divide both sides by 3. And again, find their present ages. What's the 8? Bill. So therefore, Bill is 8. And John is twice Bill, so 16. One more example, and this one takes it one step tougher because the equation's tougher. Example 1 in the booklet. A father is now only 3 times as old as his son, but 8 years ago the father was 5 times as old as his son. So, we've got a father and a son. We've got 2 time frames. We have now and 8 years ago. Okay, once again, that first sentence tells me the relationship between father and son right now. Father is 3 times son. So the son's x, the father's 3x. Now, it doesn't matter what those numbers are, x and 3x. 8 years ago, they were 8 smaller. How do you say 8 smaller? You just minus x. Or sorry, you just minus 8 from the x and the 3x minus it, from the 3x, sorry. So there is now an expression for their ages 8 years ago, and the second sentence tells me what to do. It says 8 years ago, so I'm again looking at this row, and again I'll color code this. The father, which is that number, was, that's a fancy way of saying equals. That, by the way, is supposed to be an 8. Let me fix that. Again, was means the equals 5 times as old as his son. So I'm timesing something by 5. What am I timesing by 5? The age of the son back then. So my final number necessary is that. Take a look at the way I kind of color-coded that equation. Look at the way that the words in the question told me to build that equation. And that equation is one step tougher than last equation because now x is on both sides of the equal sign. So I think I call that a type 4 equation. First step is I got to simplify the bracket, distributive property that, and I get 5x minus 40. Second step, I'm going to minus 5x from both sides. Third step, I'm going to add 8 to both sides. Don't worry about those negatives. They're about to cancel, which makes sense. It'd be weird if you got a negative age. Something would be wrong. So I divide both sides by negative 2 and x equals 16. Again, find their present ages. I've only got one. That tells me x, the son's age. So therefore, the son is 16. And how do you get the dad's age? 3 times 16. And dad is 3/16 is 48. Okay? And that's how you do age problems.